Oh, what? You're kidding me. Oh, God. Okay. Yeah, should be good. Should be live and stuff. Apparently not on Twitch though. Hmm. No, I'm live on Twitch. Okay, this doesn't show up on my phone. I think it just did actually. Did it? Yes, okay. Hello. There we go. Alright. Okay. Oh, forgot to turn my fan down again. BRB. Oh, I should turn on the music. There you go. Alright. Okay. Good. CD into stuff. There we go. Okay. So, I remember last time we did literals, comments. Actually, no, I did comments off stream before the last stream. And, what else? That's it. Yeah, we just did literals and comments, and we had the arrow already. Because that's what we tested it with the first time, you know. So yeah, this stuff works perfectly fine with the current scanner. Well, okay, it scans it perfectly fine, doesn't parse it. This does not work. This is just an example for reference. I put this all on GitHub, by the way. Forgot to do that before, even though I said in it said in the description that it was on GitHub. I lied. I'm sorry. But it should be there now. Actually, I don't have that on my YouTube description. I'm gonna change that very quickly. I'm just gonna link my GitHub account, I think. Oh, I might. Oh, dark mode. Oh. Okay. 1 second. I think this is. That's cool. Oh my god, GitHub now is dark mode. That's so cool. Damn. Alright, sorry. Okay. Oh, I should probably pin the other repository as well in that case. Where pins? How do you pin stuff? No clue. Oh, there we go. No. Is this how you pin stuff? European stuff. Okay. Man. Actions? No. Okay. Maybe just go to my profile. Customize your pins. Yeah, there we go. Save pins. Awesome. Alright. Okay, I've pinned it. And now I'm gonna go add the link to my YouTube description. So people can easily find it. On social media? Sure. GitHub is social media, right? Okay. Done. I should also add it to another thing. 1 second. Let's do a quick thingy. Edit this guy. Boom. Alright, I'm done. Okay. Yeah, I'm done. We can get to actual stuff now. Okay. Right. So yeah, put it up on GitHub. So it should all be good now. Why is he always here? God damn it. Oh, why? This why? How do I remove this? I can't, can I? God damn it. Okay, I have no goddamn clue. Okay, what did I change here? Oh, I formatted it. Yeah, okay. Let me commit this real quick. Committing stuff is so much fun. So I feel like I actually did something, you know? Oh, let me show you what I did actually, because I don't think no, because we do it off stream. But I just did a bunch of. Is that a song or an ad? That is a song apparently. Very okay. There we go. Okay, so I just did a bunch of copy paste kind of stuff. Remember the whole tokens list we had? I finished the token list up and I added all of the token types here. None of them are used yet, but they're all here, so we can use them now. All the single character thingies, minus and arrow are already done. Oh, minus equals as well. Very nice. And the multi-character ones. All the keywords, all our primitives, single line statements, blocks, a bunch of stuff. Okay, it's a pretty big language, as are most languages, except Yavi's special. And yeah, we didn't do these yet, so gotta do those as well. I'm not looking forward to doing dates, but such is life. Yeah. So I think first thing. Okay. I think first thing. Um, let's just get these single character tokens added up and stuff. Because that's just really simple, so why not? Okay. We'll leave all that there. And starting here, we're doing single tokens. Okay. Single character tokens equals um, so I believe there isn't any double characters. Let's start with equal. No. Okay, so then just self dot new token token type equal. No? What? Equal. There we go. Awesome. Next, left bracket, right bracket, left parentheses, left parentheses. Okay. Those are all also. Yeah. Okay. So then I can just copy this code, honestly. Single character ones that don't have. Okay, that's left parentheses, right parentheses, left bracket, right, right. Colon, comma, period. Colon, comma, period. Okay. So left bracket. Left. What is it? Colon, comma, period. Okay. Okay. Done. Awesome. I don't know why I said awesome. That's not the easiest thing I could have done. Okay. Alright, so next do these, but the thing with those is they also have multi-character counterparts, so what we're gonna do is just this for now, and then I'll show you what we want to actually do with them. I think plus is first, or is minus first? Plus is first, okay. Well, it doesn't actually matter if I do it in that order or not, so. But you know, I like to keep it consistent, so why not? Okay. So, basically we kind of want to copy this code. Actually, let's not copy that code. Okay. So, with star, we have two tokens that start with star. Obviously the star itself, and also star equal. So, if self dot peak equals to self.peak equals to equals, then self dot new token new token star equal else self dot god damn it star. And actually I'm gonna do this. Oh god. Actually never mind. Oh, actually no, I can just do this. Oh, that looks pretty clean. Okay. Self.peak is equals to equals that was that. Okay. And so now we can copy this code because it's pretty much the same for all of these arithmetic thingies except for minus because it has negative numbers. Otherwise, it is literally the exact same. Okay. So here, just move replace the star with the slash and slash again. Sin was a plus. Oh, actually, yeah, that's it's the same. Plus equal and plus. Done. What? Unreachable pattern? Why? How is that an unreachable pattern? Oh, whoops. Whoops. Okay. So, with slash, we have comments, so we mention the slash here first. So yeah, we gotta do the whole thing in here instead. So basically we can grab this, remove that, and replace that with this. Does that just work off the bat? It does. Awesome. Alright, yeah. Yeah. Alright. That's all this done. Uh-oh. YouTube's getting no data somehow. Never mind. All good. Okay. So then we have our comparison operators. And that's where this comes in. So here it checks for the arrow, and if it's not an arrow, if self.peak is 1, or sorry, if self.peak is equals, then we do less equals, otherwise just less. And then same thing for greater, except no arrow. Boom. Oh. Now boom. Okay. Alright. Awesome. Oh, and the lesson has another pattern to scan. I'm gonna format this a little bit better in a second. Actually, I'll just start here. No, I think that's fine. Okay. Else if self dot peak equals to greater than self dot new token so not equal. Okay. There. So I just need to scan the not equal, which is this for some goddamn reason. God, so disgusting. Let's use this, man. So much better. Whatever though. That is what it is, and it's not my language, so I cannot criticize. Oh, oh no. Okay, well actually I do need to reformat everything. Because I forgot to run self.advance. Like a moron. Because you need to advance on the equals, because we've just peaked on it here. I could, like, honestly make this significantly more optimized, I think, if I just advanced on the next character, because oh, actually no, we can't do that, because in case this is a single one, because this is not multi-character. We have to scan that as well. I don't know if that makes sense, but yeah. Okay, but we can leave the else's as they are, and we can just move them back. Yeah, that's fine. Okay, actually I'm not too upset about this. This is better formatting anyways, in my opinion at least. Oops. Alright. Okay, that's already. And then I can just do that. That's already good. This just needs a bit of help. Okay. Okay. Uh, is that done? That's done. Oh, just gotta do that. Then we are completely done. Alright. Okay. So now we can actually alright. Awesome. This should be scannable now. Um, Target 1, sample source 2. Okay, I got an error token, identifier token, star equal, slash equal. Oh, what? Oh, okay. I must have. Yeah, because I put the slash equal up there and then update it. Okay. There. Alright, let's try it again. Error token on line 2, identifier token, my ident, star equal token, slash equal token, plus equal token, minus equal token. And you also know that equal tokens work because it just did a bit ago, even though we didn't need to test it. -5, minus token, 21 plus token, 3.14 star token, -55.9 slash token, and 1. I have noticed a problem that could arise. If you do this, that should like like you should be able to do that to signify like -5 minus 21. But see, it'll get scanned as -5 and then -21. And both of those are stored as integers, same as a positive integer. So you can't distinguish between them, between the, like it technically is the same token type, so you can't distinguish between them without checking the value itself. Which is a problem, because then you can't have, you can't represent this being a minus operation in like a normal grammar for the parser. Sorry if that doesn't make sense then. Like for parsers, you say like, okay, this token type, like an integer token type, and then a plus token, and then another integer token. That's a plus operation. That's a plus expression, right? An addition expression. Now we want this to be a minus expression. Should usually be this, right? But in this case, it's just two ints, and we want this to be represented as a minus operation. So now it's like we can't just say, okay, two ints is a minus operation, because then this is a minus operation as well, which is ridiculous and completely incorrect. So then so like I guess we have to like how would we do that? I have no goddamn clue. I guess you just have to have spaces here, whatever. I don't know, man. I'll figure it out later. I don't care as much. I don't care enough to put in the effort. So that would take some work. You'd have to like distinguish between negative and positive numbers. You have to create a new whole new token type. You'd have to like know. It would be a whole thing, and I think it's better to just like better to just like tell the user to add spaces. It's not that hard to add spaces. They'll probably do it anyways. You know, just for clean looking code. It's good practice. You know. So yeah. And I'll add that in as well because we did just add that. Make that scannable. Oh, and it should work. Oh no, we haven't added true and stuff. What we can do is 1 is greater than 2, 2 is less than 5, negative 6 is greater than or equal to 0, 56 is less than or equal to x. X is not equal to x. Okay, that all should be scannable as well. You can give it a check. 1 greater token, 2, 3 less than token, 5 negative 6 greater than or equal to token literal 0, 56 less equal identifier x not equal and identifier x. Works perfectly. Okay. Let's skip keywords for a second, or not. Okay, there, because we just have keywords left. All right, that's good actually. So for keywords, this is significantly more interesting than these. Okay, it's pretty fun actually. So how we do this is we store a list of okay, so keywords they use like alphanumeric symbols, right? They're all letters, and so you can't scan them like a plus equals or like a plus or something, you know, like if you like checked if there was a B, like match in a B, capital B, and then checked if there was a O-O-L-E after it, then if someone declared a variable that was like boolean t, then it would result in a boolean token and then a identifier token with the value t, which is not right at all. It's not what you want. So what we do is what does change? Oh. So instead, we basically scan a full identifier. We think of all these tokens as identifiers, except they're reserved by the language. They're still identifiers. We think of them as identifiers, but they're reserved by the language for specific functions. And so the way we then use that sort of thinking in our scanner is we like scan a full identifier first. Where do we scan it? Okay. So yeah, we scan a full identifier. Go to scan ident. We can scan a full identifier. Once we're done scanning the identifier, right? What we do, like we know that this is a full continuous string of characters, right? While this is a whole continuous string of characters. If I added a t here, now this is a whole continuous string of characters. And so the point here is, once you have a full continuous string of characters, then we check if that full continuous string of characters is a keyword. Like this while, this starts off as an identifier in the scanIdent function, then we check if it's a keyword, and it is, because while, and then you emit that keyword's token instead of an identifier token. If I added a t here, the full continuous string of characters is while t, or whilet, something, I don't know. And so then you check if that's a keyword, and it's not a keyword, so it's an identifier. So for that, what we need to do is we need to get the text. We need to get this, right? I'm just going to get from the new token function. We basically just need to get the lexeme. There should be a way to, for optimization purposes, to pass the lexeme to the new token function if you've already got it yourself, so that you don't have to calculate it twice. But that would get a little complicated, and I don't need optimization that much. So you have the text, right? We have the lexeme. We have the identifier. So what we do is if self dot keywords dot contains text, then we do something. Okay, so I'm gonna comment this line out for now because keywords does not exist yet. So we gotta make keywords, a list of keywords, and then check if the identifier is inside it. So first I'm gonna add keywords here. Key rocks. Jesus, man. Oh my god. Okay. Hash map. Hash map. Alright. Hash map of strings. Correct? I believe so. Sorry. Yeah. Hash map of string and token. So check the string. If it's the same string as the identifier, you emit this token. We'll see in a second. Okay. So what we do here, we just create a block. This is a thing in Rust. You can create anonymous. Well, it's a thing in most programming languages, anonymous blocks, but you can do it really easily here. Just a block. You can just place it there. It's really nice. I think it might be the same in C. I'm not sure though. So what I do here is let root map goes to hash map new. and then return the map. But before we do that, map dot push insert map dot insert and the key like boolean, and the value is token type boolean. Okay. Oh. So then, the keywords map just contains a string boolean that maps to the token type boolean. Then what we can do in here, the scan token thingy is, uncomment that, and this contains the thing. Okay. Software keywords dot contains key. Oh no, I think what I do is if software keywords dot get text. Actually no. What you do is match software keywords of get text, and in the case of okay, okay T type you do something. In case of error, it's option. Oh, okay, so that's some T type. Okay. Oh no, god damn it. I've done the wrong thing. Not token type. Why did that not error? It was, huh? Oh, probably because there's an, what? Where's this error? Huh? I'm confused. Oh. Dot to string. There we go. Okay, are we all good now? Yes, we are. Awesome. Now we can get back here. Okay, match software keywords dot get reference text apparently. Some T type, none. Okay, so if you get something, oh okay. Oh, I think what you can do here. Is this feature expressed if let T type equals to that, then do something. Does that work? What does irrefutable mean? I have no clue, man. Okay, well, if we get T-type, then something. Okay. Computer's being a bit slow today. So am I. um, okay. So what we're doing here is basically if it's a sum, if there's something, when we get, we try to get the value associated with this key. If we get something, then meaning if this key is in the hash map, then the value that we get, we create a new token and return it, right? Because let's say if we write boolean, right, the text equals to like boolean as characters, then it goes in here, checks if tries to get the value next to the key boolean. It's like, okay, here's the key boolean, and the value for that is token type boolean, right? Some token type boolean. That's the value it returns. And so this here is like, okay, so it is a sum, and then token type boolean is in here. It's stored in this variable. So then we create a new token of token type boolean. We have to clone it because stuff, man, don't worry about it. But if it's like, say, x, then it tries to get the value, and there's no value associated with x, so it just returns none, right? So this if let sum fails because it's not a sum value, it's a none value. Remember options from last time? Again, I assumed that people knew what options were. Like, you have to watch the other ones to understand this anyway, so I'm gonna assume you know what an option is. So if it's not a sum type, it's a none, then instead of going there, we go to the else and just return an identifier. Right? Simple stuff. So thankfully, we don't have to do this whole thing. We prepared this. So we can just copy this whole gigantic thing, paste it in there. Oh, god damn. Tab, 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 tab. Right? Is that good? That's good. Okay, so now we have a hash map with all these values. That's very good. Good stuff. And so now we can scan. Now we can scan this because we have everything in here. So let's give it a try. See what happens. Okay, kind of excited. Okay. So to start off, we have damn it. Didn't work. Did not work. Okay. What have I done wrong? I, I didn't press save. That's what I did wrong. Alright, I got worried for a second there. Man, I am. Okay. Go to the token. All good. Declare token right here. Identifier token, my variable. Colon token, integer token, identifier token, my variable again. Arrow token, literal, integer, 10. Call token, increment, no, identifier. Identifier increment, that's good, that's good, that's good. Left parentheses, identifier, right parentheses. And then procedure, increment, identifier, increment, left parentheses, byref token, x identifier, colon token, integer token, right parentheses, identifier token x, plus equals token, literal integer 1, then end procedure. Beautiful. That's it, we're done. We're done with the scanner. It's complete. That feels good. Nice. Alright. That is awesome. Do I want to start the parser now? My internet's going pretty good. I'm not really tired. But I should probably study though. I do need to study, but then again, this is fun. Who cares about studying? Let's go. Okay, parser. Okay, I actually haven't done a full parser yet. I have finished a full scanner. I did one for Yois. I have not finished a full parser yet, though. This will be fun. I'm gonna need to use the thingy. Well, I can just delete this file. Right? Yeah. Oh, nope. I just wanted to delete keywords. Goodbye. Alright. That's awesome. That's actually awesome. Alright, I can remove these comments because both of these work now. They're perfectly fine. I can't create an example that tests every token though. That would take forever. Actually, I'm kind of tired. I don't know. Okay, I'm gonna stop here. But I am going to sort of read up on parsers and try to prepare for making a parser for this thing. Yeah, okay, this is fun. This is a good one. The last two streams have been amazing. So yeah, I'm really happy with this. Alright. Hope you did enjoy though. I should be back tomorrow. I say that every time, but like, it takes me 2 or 3 days. It's because I only stream like early in the morning. So, sorry, so I only stream early in the morning. So sometimes if I ever have to do something in the morning, or I wake up too late or something, then I have no chance to stream anymore. Because my internet only works well in the morning. Like even then it works pretty crap. But it's like better, you know. than usual. Like in the afternoon and stuff, it's complete shit. So. So yeah. Mm, right. So, okay. Well, this is fun. Um, as I said, I'll be back tomorrow, hopefully. I will try at the very least to be back by the day after tomorrow. At the very